Okay, so this is the weekly review lecture of the Computer Programming 143 subject. Okay, so the slides are going to go a little bit quickly because we've got quite a lot to cover. We've got 3 lectures to cover in roughly 30 minutes. So this thing has got a timer on. Sorry about that. Now let me first sort that out. Why is this now? Elke tweede ding gaan nou aan. Okay, I'm just going to keep it like that. You guys, welcome to join Computer Programming 143 review. Okay, I hope this doesn't disturb you, but yeah, so every Monday, 1 to 2, this is the place for that. Okay, so we've got 3 days of lectures to cover in about 30 minutes, and I only want to cover theory in 30 minutes, and the rest of the time I would like to spend on answering some questions. So let's look at what you guys had to do the past week, so that we can cover, look at some of the concepts there. All right. This lecture 1 that was given to you is just basically an administration lecture. So where all the lecturers were introduced, Professor Boysen, Dr. Jordan, Dr. Kamper, and Professor Johannes van der Spey, and I'm Dr. Danie Ludick. I'll be assisting in the practical, specifically Group 4, and also in this weekly review lectures. Alright, so I'm not going to go through all of this. All of this should be uploaded on the Sunlearn. So what I would like to do is just to recap this aim of the module, so that you guys can see what the point of this subject is. Alright, so go through all the lecturers' office hours, go through your practical times. There's a test in the practicals, very important that you answer that. Also, specifically, have a look at the times when you can go and ask your lecturer for more information. Okay, but look at the communications channel document to see what type of questions we will be facilitating in those times. So, to get back to the important aspects about this module. So, if you are going to be doing this module, then, or if you have successfully completed this module, then you will understand the composition of a computer system to some degree. You will also be able to interpret a typical engineering problem and develop software that can solve that problem. So that is a very useful skill to learn in engineering in general. And we will do this by systematically tackling any problem. Firstly, display or presenting it in terms of a flow diagram or pseudocode, and then this algorithm will be implemented in the computer. Okay, now this code, or this algorithm solution that you will write, should be easily read and understood by third parties. By third parties, that's usually the members in your team. If you have more than one person in a team. The code should be well documented. That is using comments, as we will show you a little bit later. It should be modular. What do I mean with that? Is if we have a big program that has to perform certain functions, it's always good practice to split it up into smaller, more manageable pieces, which we call functions, and that we'll go into detail a little bit later. And if we do that, then our code will be easily expandable and also reusable. So, how do we do this? We do this by implementing appropriate data types and also structures in our program. So this is what you guys will be learning in this course. Now, if you've successfully completed, you will also you've also mastered 7 control structures in C, effective use of the C standard library functions, because we don't always want to reinvent the wheel. You'll be able to effectively use arrays, pointers, characters, strings, and structures. Use of user-defined libraries. Sometimes you work in a team and you want to develop part of the solution, and the other team members have to develop a different part. Then you will provide them with a library to perform certain functions. Okay, and very importantly, that is also the focus of, I think, this prac that you'll be seeing this week, is how to start using the debugger in a little bit more detail, which will make developing your program easier. And file processing, that is also something that a programmer does on a day-to-day or a regular basis. And that's it. So, as you can see in lecture 1, there was a bit of homework assignments. I think it's very important that you guys make sure you learn this, read the study guide, read the C programming style guides. I've walked through the last practical and see quite a few of you, all the code starts in one column. That's not a good practice. It's always good practice to indent your code so that it is firstly more readable by yourself, and secondly also more readable by those that you share the code with. Very important that you read the communications channel document and understand which channel to use for questions. So if you have questions, that's more than welcome, but please try and use the correct communication channel for that. Okay, so that's a recap of lecture 1. Very quickly, simple, basically just administration. Let's look at lecture 2. Now things start getting a little bit more interesting. Let me just get this on the read mode. Okay. We're now going to look a little bit in more detail, or have a little bit more detailed introduction to C. So, firstly, an introduction to C, a little bit overview of computer systems. What is programming languages? That is how does it work? And also we'll be looking at our first C program, very simple program that is used to print a piece of text to the screen. Okay, so in this introduction, section 1.1, what was the goal of that? It was to start thinking in a structured way in which to solve problems using computers. And we're going to do this using the C programming language. It is a wonderful fundamental language that will enable you to go or to learn other languages in your career much, quite simply, because it provides you with the correct building blocks, or the correct foundation. Okay, so this textbook, later chapters 15 to 24, also covers C++, but I don't think we're going to worry about that now. Today our focus is just on the introduction to C. So this course is useful for technically oriented people, but also advanced programmers that would like to have a more in-depth understanding of the language. So I'm not going to stand still on what a computer is. This you should have done in grade 12 computer science or something similar. So a computer consists of a device basically that is used to perform calculations, and it's got various input and output. And the software, that is the stuff that we'll be developing, runs on that computer. Here's just an overview of all the various hardware components. We've got the CPU, memory controller, disk controller, display, and also the keyboard controller, and all of this communicate with each other on a system bus. Now, the 6 logical units in every computer, so there's input, output, arithmetic, logic unit, ALU, this is where all the mathematics works, the central processing unit, what that basically, the CPU, all of you should have heard about that just supervises and coordinates all the processes within the computer. Then you have something called RAM, random access memory. It's volatile, that means it loses its value if the power shuts down. Programmed, but it's fast. It's quick to access RAM, and that's where programs live when they are executing. You also have secondary storage units. The secondary storage units are disks. That's the hard drives. They're cheaper, more longer term, higher capacity storage, and that is where all the files are stored. So all the inactive programs are stored on the hard drive. Hard drives are undergoing quite a lot of development as well with this new solid state drive technology and so on. So these things are also becoming faster and faster. Okay, how does computer programming languages now fit into all of this? So it basically works in steps of levels. So we talk about low level and high level. So at a very low level, that is when something interfaces with the machine with what we call machine-specific instructions. And then things are programs are represented as strings of numbers. Then you go a level higher, then you start going into assembly languages, and then we start seeing that, okay, now this stuff starts to become understandable by someone that can read English. So you can see load this variable base play, add the variable overplay, and store the variable gross play. I think in later years of engineering, electrical engineering at least, you still do a little bit of assembly programming, but we're not going to worry about that. Now you get higher level languages, and that's where C fits in. And also, even above that, other high level languages like C++, Python, MATLAB, Octave, all that type of stuff. But higher level languages enables us to write programs similar, in ways that are similar to everyday English, how we talk. And we use quite a lot of mathematical notations for this. Now, our English code is, or it doesn't have to be English, but the code that we write that's in a human readable format can then be translated to machine instructions that a machine can understand, and that is done via a compiler. So that's the function of the compiler that you guys invoke from the Eclipse IDE environment. That min-gwcc compiler translates the code from readable English into something that the machine can understand. And this is just an example of how that assembly instruction in the previous slide can be written in clear idiomatic English. Okay, just a couple of points on why we use C in this module. As I've already said, it highlights programming principles very, very nicely, and that paves a solid foundation for you to go over to other languages. It is also essential for embedded applications, applications that runs on microcontrollers. All of that embedded C is written in the C language, so or a lot of it at least. And it contains many libraries for mathematical and scientific applications because the language has been developed and improved over so many years. Okay, so this is a bit of a history over C. I'm not going to go into that. I'd rather spend time on the implementation side, but you guys can read through the textbook in this section. Something very important, the C standard library. So, C programs, we don't write everything in a main. What we do is we call certain functions or modules. So, where do we get these modules that we call from? Firstly, a programmer can create his own functions or her own functions. The advantage is that the programmer knows exactly how it works, but the disadvantage is that it's time consuming. Okay, so if we need to develop a function that calculates the square root of two numbers, that is already contained in a C library function that you can import and that you can use. So, if you use these building blocks, that saves a significant amount of time, but you should know, and it's very good practice to understand exactly how that library works, what is expected as input and what is expected as output. So that you will see when we declare at the top of a program, we declare hash include standard lib or standard IO. So the standard IO library, as we will see a bit later, is used for input and output of the software. Okay, so the basic premise in engineering always boils down to the fact that we don't want to reinvent the wheel. If a pre-made function already exists, it's much better to use it unless you require other more specific custom behavior. It is much easier to call that instead of writing your own. Alright, so a typical C system therefore consists of the program development environment. What we're using is Eclipse for that, the language, obviously the syntax, the code that we write, as well as some library functions. And there's a couple of phases that a program goes through in its life cycle. Firstly, the code is obviously edited in the IDE or the text editor or so on. That's the code is written. Then it goes through a pre-process step whereby we basically evaluate the syntax. Goes through a compilation. Remember a couple of slides back we said that the code compiles from a human readable format into something that the machine can understand. It gets linked. So with linking, you'll see now on a diagram, on this diagram over here, what linking is. Code is loaded into memory and then it executes. Okay, so let's present this as a graphical overview over here. So we've got the editing, and the files that we're going to edit in this course is C files. So you've got your source C file, but also, as we will see later, you have these header files that is used to define function prototypes of certain functions and modules and so on. these human readable files, they go through pre-process and a compilation. So they are translated into machine type language. Then out pops what we call object files or a library file. And then our linker, which is all integrated into the same IDE that we're using in Eclipse. The linker combines all these object files that it loads and executes in the form of a single executable. If we work on Windows, that is the .exe file that you see. Okay. Now, let's look at a very simple program. What happens, this is a program, this is what we call a Hello World program. So firstly, we've got our comments at the top here. This is the green over here. We've got, it's always good practice to add something for your file name, brief description, version. If you work on a file that has a lot of versions, you can add that, the date, and the author. As I said, this line, #include stdio.h, that is the standard input-output library of C that contains a lot of routines that is used to write and read text from the screen. So that contains information about this printf statement, for example. So as you can see, I can put my comments in any part of the file using these comment delimiters, this / and an asterisk. I begin, all C programs has to have, there's one entry point in the exe, and that is this function called main. So main is an integer function, that's why it's got the name int here, and it takes no input arguments. It's got a curly bracket that starts the program, and a closing curly bracket that encapsulates this part of the function. Okay, so inside there's just the printf with two signs over here, and it says hello world, and this delimiter over here, \n, that is a new line character. Okay, and we return finally, because main has to return something. It's returning 0 here, which says that my program executed, and my program ended without any issue. Okay. Now, if you run that program, which you should have seen by now how to do that in the Eclipse environment, the output is going to be hello world. Okay, this just explains each part of it. As I said, how comment works, why the return 0 statement is there. Very important, when you write your programs, add this semicolon at the end, otherwise your statements will generate a syntax error. Okay, here's some information about what I said, this includes standard IO libraries and what main is. And the braces. Okay, so this indicates a block. All the code inside that block is associated with that particular function, and the printf statement is explained over here. Okay, so that was basically lecture 2, where we went through these components over here, and we've also been able to write our first C program, which I believe you guys should have done successfully in last week's practical. So now, in the next lecture, which we're going to do now, we're going to look at arithmetic and also user input. So we have about 10 minutes left. Let's do that. Lecture 3. Okay. In lecture 3, what we have over here, this is just a bit of a roadmap to see where we are. We are still busy with chapter 2. We are going to be printing text and to integers, a little bit about memory concepts, arithmetic, and then a simple program where we're going to read user input. This information over here is going to be very useful for the practical this coming week. So, what is an escape sequence? Let's look at that. Let's just look at what the printf statement, we manipulate that statement a little bit to print text to a screen. So at this point we're going to introduce the concept of an escape sequence. This is the new line, this \n that's printed over here. That tells the compiler, this tells the program to print the text following it on a new line. There's a couple of these escape sequences. There's the new line, tab, alert, all sorts of them. I urge you to, in your free time, please practice that. Add, for example, a T in the printf statement and see what happens. Or an A to sound the system alarm bell. Okay, let's look at adding two integers. This program is a little bit more complex than the previous one that we saw. We have our hash include, our standard library. We have our int main with the block of code over here. This part is where we declare two integers. Integer 1 or three variables. Let's start with that. We have got integer 1, integer 2, and sum. These variables all have the type int. That means they're all integer variables. Here on these lines over here, we assign the values, and over here we output the values. And if we run the program, that is the output. So basically, integers has to have a name, it has to have a type. The name can consist of letters and digits, but the integer cannot start with a digit. And very important, C is case sensitive. So capital letter A variable name is not the same as a lowercase letter a variable name. Variables, declarations must appear before the executable statements. Okay, there's a couple of reserved keywords. Obviously, these should be reserved for particular C functions or types and cannot be used as variable names. Take note of those. And there's also, how do we print out certain variables? There we have special characters to denote this. So this percentage %D tells us to print out the value of an integer. Okay, so a variable basically is used to allocate a piece of memory for us where we're going to store a variable. That's why we need to declare them in front over here, called int integer 1. So this reserves an integer space in the memory for anything that will be added in that value, integer 1. So if we say integer 1 is 45, 45 is going to be stored in memory at that particular point, as shown over here in these memory addresses. There are also other types of variables. There's chars, ints, floats, quite a few, char arrays, which is strings.
Okay guys, welcome back. Sorry about the momentarily interruption over there. As I was saying, you get different types of variables. You get a characters, which is a char. It's stored in 8 bits, that's 1 byte, and it can take this value from -127 to 127. Then you also get other types. You get a char array, which is used to store a string, integers, which is specified as shown here, int. Then you have decibels of type float. So int and float you're going to see quite a lot in scientific processing, but you'll also be using chars and char arrays for string manipulation. Okay, so in terms of arithmetic calculation, this should also, so you have this sign, this asterisk for multiplication, and this sign here for division, the /. You also then have, this is a very important quantity, very important point to remember. Integer division truncates the remainder. So if you have 7 divided by 5, how many times can 5 go into 7? Only once, and then there's a 2 left over. That will, in C, if you do integer division, that is if you write 7 without a decimal divided by 5 without a decimal, that will evaluate to 1. Then we also have what we call the modulus operator, or mod in short. This is this percentage sign. This returns the remainder. So if you say 7 mod 5, that will be 2. How many times does 5 go into 7? Once, how much is left over? 2. Okay. Just as in mathematics, these operators also have certain precedence. So you're going to start off with, that means certain operators will act before others. So, for example, multiplication before addition, or parentheses before any of them. Alright, so let's look at some of the arithmetic operators. Here we have addition. That's shown just with the plus sign, subtraction minus sign, multiplication, as I said, with the asterisk, division with the /, and modulus with the percentage. These are the algebraic expressions, and this is how you will write it in C. In terms of the operator precedence, that's detailed on this slide over here. So as with maths, you do first you're going to do the parentheses. and then go over to multiplication, division, and modulus, and then plus and minus. Okay, so let's look at a slightly more complicated example where we are going to use our scanf routine for reading input from the user. So, as shown over here, you have your include standard IO, which is including your standard input-output library. We start our main function, we declare our integers, integer 1, 2, and sum, and we set our buffer. This should have been explained to you in class. But in short, it's just basically fixes Eclipse for the scanf. So it's very important to include this line. Printf, we're just going to print to the screen, enter your first integer, and then we're going to call the scanf function. So the scanf over here reads in an integer defier. As you can see, this %d means we are going to read integer 1, which is of type int. And the second argument is the integer 1 in which you're going to store this user input variable, and it's preceded with this ampersand. This ampersand is very important to remember when you execute the scanf, and it is it will be covered in future lectures. So don't need to worry about it too much now, but if you don't include it, this will not work. Then we do the same with the second integer. We calculate the sum of the two and we print it out. And your output should be as expected, as shown over here. Okay, again, the setBuff, just in short, is a function to set up the output of Eclipse to receive characters correctly from scanf. So, for all practical purposes, when you use scanf, please add this setBuff routine. Now, just here's a bit of an explanation about what this scanf function does. It's a %d. As we said, this %d is important. That indicates data should be a decimal integer. There are others for floats and character arrays and so on. Then we specify where's this %d going to be stored in integer 1. And this is the location in memory in which to store this variable. Now, as I said, this ampersand, don't worry about it too much now. In future lectures, we're going to see exactly what's meant by it. Now, so when executing the program, your user responds to the scanf statement by typing a number and then pressing the enter or the return key. Okay, so just a bit of perspective about where you currently are in the course. You should have been able to write about 2 programs, one to print an arbitrary line of text and the other to add 2 numbers. You should know by now that variables hold the memory positions where certain values are being stored, and we also looked at a couple of arithmetic operators. And we've also looked at a function called scanf that can be used to store user input. So more on the other lectures, the review lectures next week, and please remember to use the communications channel document if you have any questions. Thank you.